So today we're going to be looking at section 12.3, the ellipses. And let's take a look at those and see what an ellipse is. So an ellipse, by definition, is a set of all the points, okay, such that the sum of these two distances is constant. So every point on the ellipse, these two distances from these two fixed points called the foci will be exactly the same number. All right? We have, you can see that's kind of elongated in one direction. So this long side right here, if I draw a segment all the way across through the foci to the other side, it's going to go through the center. It's going to touch the curve at these two locations. These locations are called vertices, and this is called the major axis. The major axis contains the vertices, the foci, and the center. Okay, if I draw a line segment through the center this way, it'll hit the curve here and here. These 2 points are called co-vertices, and this is called the minor axis. Okay, so what we want to be able to do is determine this distance from here to here and this distance from here to here. Okay, where the center is, the foci, and all that stuff. And does it go this way horizontally, or does it go in a vertical sense? So how can I tell? Well, let's look at this. So here are some ellipses centered at the origin. And you'll notice that the major axis, the vertex over here is at A. If I look at it this way, here's the center, and the vertex is up here because the major axis goes this way, and the vertex is at A on the y-axis. What this means is that A is the longer number, the bigger number. And so then I can look into my equation. Where is the A squared? Well, on a horizontal one, the A, the bigger number, is under the X. And on the vertical one, the A is under the Y. This means whichever number is bigger underneath, okay, that's going to determine if it's horizontal or vertical. Okay, so here's our layout here for our equations. You can take a look at that. So if A is larger and it's under the X, then it'll be a horizontal major axis. The vertices will be at these 2 points, and the co-vertices will be at those points. And likewise for the vertical in that sense. In this case, C, where the foci are at, C is the units from the center, that's where the foci are, is A squared minus B squared. So you want to make sure that you remember that little change there. Okay, so here's our equations. We're going to go do some problems associated with this. And let's go take a look. Here we go. The first one is, how do I draw an ellipse? What do I need to do? Okay, so in this particular case right here, we want to put this in the proper form. Right now it's in the general form, and you can see clearly that the coefficients are different. The two terms are being added. They're both positive, which means this is what an ellipse looks like. Okay, if these numbers were the same, then it would be a circle. But since they are different, it's an ellipse. If one of these was a negative, then it would be the hyperbola. So the first thing you want to do is divide everything by 100. And when I do that, I'll get 4x squared over 100 to 25y squared over 100. So just divide everything by 100, because I want this number out here to be a 1. And then what I get is, after I reduce my fractions, I get x squared over 25, y squared over 4 equals 1. And now you're in the ellipse format, and I can see that A is the plus or minus the square root of 25, which is plus or minus 5, and B is the square root of 4, so plus or minus 2. I can find C, because C squared is A squared minus B squared, and so I know that C is going to be at plus or minus the square root of 21. And you can get a calculator to approximate that out. So I can go and graph these. I know it's horizontal because the bigger number is under the X. So I know that it's going to go in this fashion. The vertices are at 5 and -5. The co-vertices are at 2 and -2. And then here's the center. So what we're going to do is we're going to try and draw an ellipse from this. Try and make it roundy, don't make it pointy. Okay. So as you come across here, just kind of make your little roundabout stuff. And there's an ellipse right there. Okay. And we can label these. This is 5, 0, -5, 0, 0, -2, and 0, 2. There's your vertices and co-vertices labeled. The center is at 0, 0. And then where is C, the foci, at this point right here, which is between 4 and 5, because the square root of 16 is 4 and the square root of 25 is 5. It's closer to the 5 than it is the 16, the 25 than it is the 16, so it's closer to the 5. So this right here and this right here is about where the foci are. So this point right here is the square root of 21, 0, and this one over here is a negative square root of 21, 0. 2 foci. And that's how you can label them all out. Okay? So we come over here, we look at these. We're going to write these equations from this information that's given right here. Here they tell me the vertex is 0, 5. The vertex is always associated with the value of A. So that means this is 0A, which means A is 5. The covertc is associated with the B, so the B is on the x-axis. So that means B is 4. So from that information right here, we know this is going to be a vertical, okay, ellipse, which means it's going to be x squared over b squared, and then y squared over a squared equal to 1. Okay. Over here, a little bit more involved in this one. Here we have the vertex at -6, 0. So that means A is going to be that plus or minus 6. It is on the x-axis. Okay. The focus then is also on the x-axis, and this means that C is 3. Okay. We can use this information right here to find B. So C squared is A squared minus B squared. So we put in our 3. We put in our A, and we solve for B. So moving things around over here, you'll get B squared is equal to this number, which is 36, minus that number, which is 9, which is 27. So B squared is 27. I don't even know what B is. I just need to know what B squared is. A is bigger, so it's going to be under the X. Y squared. B squared is under that. And it's equal to 1. And there you go. Okay. Let's look at some more problems. So here's another problem. So this problem right here is an amusement park has a garden. Okay, has a garden. And it's 32 feet long and 14 feet wide. So if you draw a little quick sketch of what an ellipse is, it's longer in the X direction than it is in the Y direction. That means that is a major axis, and that length is 32. This is the minor axis, and that length is 14. But these things divide it all up. It's got to be even. It's going through the center, which means A, based off of that, A is 16, half of 32. And B is 7, which is half of 14. So once I know that, then I can just plug it into my equation. And so I have x squared over 16 squared, y squared over 7 squared equals 1. And then you can actually figure out what those values are and write it out. Equals 1. And there you go. The area is kind of interesting. So for an ellipse, if you think about an ellipse and a circle are very related, a circle's area is pi r squared, but an ellipse is pi AB. Okay, pi times that times that. So just kind of interesting, I thought. Oh, we already know what A and B are, so we just plug them in, and this problem becomes fairly simple. 16 times 7 times pi square feet, and there you go. Okay. This one down here is the orbit of the moon around the Earth. And these are the distances from the center of the Earth that the moon travels. It's an elliptical orbit. Okay. But the center of the Earth is not the center of the orbit. The center of the Earth is the focus of the orbit. So if we kind of draw a quick picture of what this looks like, and again, it's not drawn to scale or anything like that. So consider this point the center. Okay. And then over here is a focus. This is the Earth's center. Okay. Here's the major axis right there. This distance would be C. This distance is the larger number. And then this distance, although it's not drawn to scale, you can tell, is the shorter number. So what we need to do is use this information. That's why you always draw a picture. You want to use this information to help us figure out what's going on. We want to find that A and B, we're going to have to use the C value. We've got to find what C is. And we know that C squared is A squared minus B squared. So we got to find C to start us off. Okay, there's a couple of ways to do this based off of what you're looking at here in this picture. One way is to recognize that this right here is the center. And the way I have it drawn, this distance plus that distance is the whole major axis length. So I can add those together and then divide by 2, and I will get A. So that is one way to do it. Let me show you that one method over there. So I take these two numbers, 500, and add to that the 252,000. I get 473,500. If I take that number divided by 2, then I'm going to get this value, which is A. Okay, so that is A. And if that is A, then I can take A, this distance right here, subtract this value, and I'll have C. So that means C is the whole thing, the A value, minus this number here, since I have it, and I get C to equal 15250. So now I have C and I have A. Okay, there's another way to show you this. So this is one way. Another way that I saw would be this. A is this distance, so this number plus this number, and A over here is this distance minus C. So I have 221500 plus C equals A, and 252000 minus C equals A. So these both equal A, and I can solve this, and I get, move the C over here, you get 2 C's is 252000 minus this, and what you end up with is subtract that, divide by 2, and I get C is equal to that same number again. And if C equals that number, then I can find the A number, which is just, since I know C, it's this distance plus that one, and so I have A is again the 236750. So 2 ways to get the same answer, just so you can see it. Okay. Once I have these 2 numbers, I can find B. So 15250 squared equals this squared, and then find B squared. So moving things around, I get B squared is equal to 55818,000,000. So a very large number. I can take A and square that. Gives me 56050562500. Again, very large number. But I have my A and my B, and this allows me to plug it into my equation to find the orbit's equation. So A squared is on this horizontal, so A is this. So 5056250, and then the other one. And there is the equation for the moon's orbit around the Earth. Okay, so we'll be doing some more problems together in class, but that is this video.